Welcome everyone to a new IoT tutorial, and in this tutorial I will going to discuss home automation with Tasmota using ESP32. So for this project I will be flashing the ESP32 with Tasmota firmware, and we will be connecting with MQTT using the Tasmota, and this is just a first part for our home assistant. Basically in the future videos I will be covering the home assistant and will create dashboard for controlling our home appliances. For now we are just going to control the LED of ESP32, which will you can consider it as a relay, and you can control n number of appliances for your home. So moving forward, we have these are the agenda for this session, which are the requirements. We will see the requirements for this tutorial, and then Tasmota firmware installation for ESP32. We'll see all the steps, basically the softwares we need. Then we will, using those softwares, we will going to flash this Tasmota firmware to our ESP32, and then what we need to do is basically set up the Wi-Fi credentials so that the ESP32 will get connected to our router. This will also need a new software, and the fifth step is that to update the GPIO settings. So GPIO settings need to be updated also, so that we can configure that which pin we want to use as a relay. And at last we will going to see the MQTT configuration for communicating with our mosquito broker. So for this demo I will going to use the Hive MQ broker, which is also MQTT broker. So let's see the demo first. Now you can see in the bottom left corner we have our ESP32, for which the red LED is basically turned on, and we will be basically toggling the GPIO pin 2 for this ESP32, and which is basically connected to the built-in LED for ESP32. So I have configured the Tasmota, and the configuration for, and the relay pin is basically GPIO 2. So for turning on the built-in LED for ESP32, we need to send the command on. In for this topic we will understand that how we are going to send specifically for this topic in the demo in the tutorial section. Let's publish, and you can see that the blue light is turned on, so which is basically, if we connect a relay module relay with this ESP32, basically it will be turned on. And we can also see that we are subscribed to one topic, stat/tasmota_gignes/result. So we have also received the message, and if we can see that we have already received a few messages which has like uptime, how much time this device is turned on, and the load average, MQTT, cloud and power, Wi-Fi, everything is there coming to this topic, which is this one. So we will be going to discuss this in the tutorial part, but for now this is how the MQTT part is working from here. So if we want to control the same from the Tasmota dashboard, the web UI which is given by them, so we are just if you can see this is the device, it is connected to my router, and the IP address is this one. If we navigate to this IP, we will see this web UI. So for toggling on, it is currently in on state, so okay, now it's in off state. So we can also do the same from this part, and we are going to discuss each and every things: configuration, information, firmware upgrade. We can also do the firmware upgrade, like upgrade the firmware, basically the Tasmota.bin firmware, and we'll see that in the demo also. Talking about the requirements, so we need a ESP32 or ESP8266 and a mosquito broker. So you can basically download the mosquito broker for your system, a local mosquito broker, or even in this project I am using the mosquito. Basically I am using a cloud MQTT broker. If I can show you, you can see broker.hivemq.com:1883. so this is a public broker and public cloud broker which I am using in this project. So let's move to the slide again, and So these are the two requirements you need to have. And the second requirement can be like you don't have to install the locally, you can also use the cloud hosted public brokers, MQTT brokers. So this is the main part, the Tasmota firmware installation. Okay, so ESP8266 based devices, we need to move to this URL. And for ESP32, which is basically the focus of this tutorial, so for ESP32 we need to download the Tasmota 32.bin from this link. So I will provide this link in the description of this video. So just click on this link. I will move forward to this page. Okay, and it is downloaded. Fine. So you can see that we have this Tasmota 32.bin, which I have downloaded from this link given here. And apart from that, we have to basically for going through the documentation, there are links given to us, tasmota.github.io/docs for going through the documentation. And for ESP30, specific for ESP32, we have also the documentation for that. Let me go through it once. So you can see that for flashing this Tasmota firmware to ESP32, they recommend to use ESP_flasher for Windows, Mac OS, Linux, or Tasmota web installer also to flash. But what we are doing is, for flashing the Tasmota firmware to ESP32, we are basically going to use ESP home flasher. Okay, so and this is specifically for ESP32. So this is the one which I have tested and it is working very fine. So although it is saying that these tools are good in the documentation, but we can't like rely on this, since this support is in beta phase, like still in testing. So what for me, this ESP home flasher is working fine. So you can download this software. You can simply search for this software on here, and you can see that we have this one link. And there are 14 releases. If we can see that there is .exe file for Windows. So if you have 64-bit system, x86 architecture is there for you, and sorry, x64 is there. This is for 64-bit, and this 86 is for 32-bit system. Okay, so for Mac OS or Linux, .zip is also for Mac OS. Zip is also there. Ubuntu.exe is also there. So I have already downloaded the .exe file, and so after that .exe file, you need to simply double click on this one. Okay, so let me flash this Tasmota 32.bin to our ESP. So first what you need to do is, the first step is to connect the ESP32 with your computer on which this software is running. So I have already connected it. So let me see. Okay, so we have a drop down and it says COM4. So my ESP32 is detected on COM4. So select it. So here, from here, we need to give the firmware location. So we need to simply click on browse here, and Tasmota with ESP32. Okay, so in the here .bin file, you need to simply click on open. Okay, after this you can simply click on flash ESP. Okay, so I have already Tasmota 32.bin already flashed. So let me try once again. So let me flash once again. Okay, so there is no problem in that. Okay, so first it is erasing. You can say it is now start uploading 27%, 30%. So it is uploading the firmware 4950, and okay, so you can see that. So we have already flashed this firmware, and now we can see at the end it says Wi-Fi manager active for 3 minutes and web server active on Tasmota underscore E3 with IP address this one 192.168.4.1. So if you navigate to this IP, you can't basically access this IP address. Okay, so in this case, first what you need to do is, since it will not able to connect, this ESP32 will not able to connect to our Wi-Fi since we haven't provided the credentials yet. So the next step is, let's follow the PPT and okay, let me okay. So this step is set Wi-Fi credentials using serial channel. Okay, so for this part, for setting up the Wi-Fi credentials, now what we need to do is install Termite. So Termite is a software. You need to install it from the website. You can simply type Termite software, and you will get it from termite.software.informer.com. Version 3.4 is the latest one, and I have installed the termite version 3.4.exe. okay, so it will be around 332 kb, not much more than that. And after that, just what you need is, you need to open this termite. Okay, so there you want to allow this app for making changes to device. Basically a warning is there from Windows 10, and then simply set up this. Okay, so you can next and like set up everything, just next, and you can install the software. Okay, so since I have already installed this, I will simply open the software now. Okay, so here I have opened the software, and we can see that COM4 is already selected here. Okay, now it is disconnected. So okay, now it is COM4 115200 bps. So baud rate is there, and COM4 is the port which on which our ESP32 is connected. So if it is not, then you can go to setting and set the baud rate as this one, and port as the port from drop down COM4 or anything that is your port number for your ESP32. Okay, so after all this thing, you need to enter few commands here. Since we are basically termite is initialized and ready, so we need to follow these two commands for setting up the Wi-Fi credentials. So this is the first command, just copy it, and okay, you can close the ESP home flasher. Its work is done from here. Okay, so simply paste it, and name of the hotspot for this you need to provide the hotspot name or your Wi-Fi name, your router name basically. So for me it is standard underscore 10 df10. Okay, so okay, and simply click and enter. SSID 1 is selected. Okay, great. So there are few commands, and now we need to also set the password. So for me, here is my password. Yeah. So now it is trying to connect. Okay, web server active on Tasmota. This one with IP address is also given. This is the IP address 192.168. Okay, and now you can see that things are getting, MQTT data is also getting on these serial channel. We have this data coming from the device from there. So you can simply copy this. Okay, and even if you will check your here parental in your Wi-Fi, you can see that a device Tasmota underscore some ID is connected to your router. If you are using a router, you can see on the router page, and but if you are using a mobile hotspot or something, you can simply copy it from termite software, this IP address, and simply paste it here. Okay, and then make enter. Okay, so now what we can see is ESP32 dev kit Tasmota, and this Tasmota is basically installed and working fine. And the next step is configure MQTT. So before configuring MQTT, what I need to do is configure the ESP32 with this Tasmota. So for that we need to click on configuration, and then other than configuration module, configure module. Okay, so okay, module type already selected, ESP32 dev kit 1 or 0. Okay, so depending upon your ESP32 manufacturer model, so for my it is from AI Thinker, so it is dev kit 1, or it is I have already checked that it is fine. For the built-in LED of ESP32, we have GPIO pin, and we can select that we want this as a relay, and we can add 28 relays on this ESP32. So this is just our first relay. Okay, so this is the relay and it is our first relay. So now we can control this relay. Okay, so just save it, then I will show how do we control this relay, first relay. We can control multiple number of relay using MQTT, as we have already seen in the demo. In the demo we have shown for only one, but I will show you the documentation that how you will able to control multiple pins of ESP32. So it will take some time, and it is currently, you can see it is refreshing. Meanwhile we can like go through the documentation. Like after this point we will going to see the first if the GPIO2 is working fine. Okay, now you can see there is something more like off and toggle. So this thing came from that first relay we have added. Okay, so if I can show you the hardware setup now, and toggle, you can see the blue light is turned on. For it is basically the GPIO2 connected built-in LED, and is okay, turned off. Fine. So this is the thing we have achieved till now. So let me turn off this demo for now, and so for the next step we are going to configure MQTT. So in that case we need to configure Wi-Fi, configure MQTT. So there is MQTT here, and we have multiple things. For Tasmota, I would like to give you a small demo, like a small talk, like why is Tasmota so popular. So basically Tasmota is a firmware for ESP8266 based devices like ITED, Sonoff. These ITED and Sonoff are from EV-Link, you know, and with web UI, since we are getting web UI with Tasmota. You have already used other firmwares, like the basic firmware is like we use the Arduino IDE to upload the sketches and things like that, but for this thing it is generally used in home automation scenarios, and where we want the web UI, and we want this Tasmota to be all simply configured using MQTT without writing any a large number of codes using Arduino IDE. So what you need is basically this simple web UI, simple configure MQTT button. You need to simply give the broker URL and define the topics, and you can easily control your devices, control the release. Okay, so the release I have added, so you can control it over MQTT, over HTTP, serial, or KNX for integration. These all things are we have given, and it is very helpful in home automation systems, right? So this is the Tasmota firmware useful for. Okay, so we have the over the air OTA support for Tasmota. Like I have already talked about this in the beginning of this session, that firmware upgrade option is available with us, and we can simply update this URL, and for the new OTA, for the new firmware we will just update this URL with that and start upgrade. Okay, so or we can even upgrade a file upload and start upgrade. So these are the two options we have right now. So we have covered a basic of Tasmota, and now we can simply jump to our MQTT part. So simply click on this configure MQTT, and here for for the cloud broker which I am using is HiveMQ. So broker.hivemq.com, and this is the host name for that, and then the port is 1883. This is the port where there is no need of user name or password, there is no authentication for this public broker. And in the real scenario, when you are working with your devices in your home, so what you need is basically you need the user and password both. And okay, so authentication is the main part, because if not, then anyone can connect to this broker since it is a public broker, anyone can connect to this broker and like turn off or turn on your device, or get control over your devices, right? So you need to take care of this thing. And client id dev underscore %06x. okay, so it is generating a random client id right here. Fine. And topic we have and full topic we have. So before writing these two things, let's understand this, what is these two things from the documentation. So MQTT is right here. So you can see after you have working, we need to configure Tasmota to communicate with it. So you can learn configure using web UI. Fine. So the main part is the host name we need, the port we need, client, the user password. It is when it is needed when it is configured at the broker end. So if you want that, if our broker doesn't need the credentials, then there is no need to put this username and password. So for public MQTT broker, there is no need for that. Like you need just this TCP port and broker URL. Fine. That's why I haven't used the user and password part. So for topic, it is a unique identifying topic for your device. So since we have this ESP32 with us, so you can say it like you can place it in any of your room, like kitchen, and control all your relays, all your lights or similar things on in your kitchen. So you can like simply name this ESP32 device as kitchen light or hall switch, anything like that. So it should be unique, right? So it should be unique, and it is recommended to use a single word for that topic. Perfect. So this is the recommendation. It is not necessary, but but I prefer to write a single word also. So in this case, what we can do is we have Tasmota underscore, since we are using a public broker. So if I can show you this thing, okay. So we have this so we know that this if we make it a simple thing like test or similar thing like that, so then anyone else also name this topic as similar. Since we are using a public broker, so we need to make this topic very specific, so that no naming class will happen, because if this will happen, then other can also like turn on or turn off our device. So for that, in that case, I will prefer that you will put some unique ID Tasmota underscore. Okay, so let's put my name here, and for the full topic, it will generate the full topic using this topic. So prefix slash topic. So for the prefix part, what we have, so okay, let me say this one. So prefix part, we can have very few things like cmnd is one thing. Prefix can be cmnd, command, stat. These are the prefix we have. Okay, so full topic will be created based on command, stat, and all these things. So what is these three things? Let me show you that also. So Tasmota uses three prefixes for forming a full topic. So the first prefix is cmnd. So it is used, this prefix is to issue command. Okay, so basically it will be giving us topics for which we are going to send data to. So we are going to send data to the topics which start with the cmnd. So that is the use case of that cmnd. The start is for report back status or configuration message. So report back, so if it will give us the message back, so it is basically for subscription part. So it will start from stat. So this is the prefix. And tally is for report telemetry info at specified intervals. Fine. So if I can add one more subscriber, and paste it, and simply from stat you can see tally. Let me see also there. Okay, perfect. So we have these three things, and but we don't we have for the topic part, you can see that I have set it as Tasmota underscore Jignes. Okay, so it is fine. Okay, so but we haven't saved it yet, so simply click on save button. So it will take few seconds and it will restart, and after restarting we are going to get this topic configured, and then after we can get the telemetry data information on this topic, since basically the ESP32 is publishing data on this topic and also in this topic, and we are going to publish data for controlling our relays on this topic, power topic. Okay, power result and result. So we can check if anything else we can get from this documentation, like ask the device for status. So this power and emptying payload send as status query. Okay, so we can see that it is refreshed till now, and now we can simply subscribe it, also subscribe it, and if I can turn on my demo part, you can see that power on and power off. Fine, you can also see in the demo that we are controlling this thing via MQTT. So you will be basically getting more control and more best dashboards when I will going to configure this MQTT part locally with our with our home assistant software dashboard. So it is provided by HasIO, so we will be going to cover that in the next session. So that's all for this video. You can find the circuit diagram and the software links in the description of this video. Please like, share and subscribe for more videos like this, or if you have any idea, join us to collaborate, or if you want to develop any IoT based project, please contact us. Thank you.